the build completed. If only I could time everything so that these hourly breaks would be like we'd do a build. But it doesn't always work out like that. All right, so what we need to have open here is we need to be able to see what's going on with the task worker. Okay, it's running. And then Redis, yes. I don't know why Windows decided today that this screen would be. Oh, you know what it is? So if I do like Windows tab, right? Then the thing that shows all the windows is on my other monitor. But if I whatever I did a second ago shows it on whatever monitor the cursor's on. Okay, so anyway, let's we don't need that temporary queue anymore. That was a failure. We'll get back over here and queue up our task again. There we go. You can see it immediately saw that happening. And then if we go over to the silence detection API, there we go. We're processing. Should take about 30 seconds to process one video and detect the silences using FFmpeg. We worked on that a few streams ago. Now, if you're watching this and want to know how we got to here, pretty much this whole thing was streamed. Awesome. Pretty much this whole thing was streamed, and the VODs don't stay around. Hold on, let me see, be a little quiet. The VODs don't stay around forever on Twitch. So I do cut up the video from the stream, and I upload it over on my Sabin VODs YouTube channel, which you can find here, just for reference. I know there's some people that come across those videos that way, I think. But yeah, okay, so we got the task data. We got our response, and you can see there's like a cursor and then the segments, and we say that we finished the task. So if I ever to refresh over here, I would expect that I would see, oh hey!
Hamid Baitani just followed.
Hamid Baitani. I'll go with the text-to-speech's pronunciation. Hope that's okay. Thank you for the follow. If we were to refresh this now, I would expect to see a new key here, a task :1 : data, right? That has the list. Yeah. Welcome. Welcome to whoever here is lurking. All lurkers welcome. I see some familiar names too in the viewer list. So hello to you. I won't name you. You don't need to be called out, but thank you, Mrs. Crazy Walk, for being so welcoming. All right, so we have a list. I guess now I am checking the list, am I not? I may check it again. Look, I have to acknowledge a little bit that it is Christmas time. Anyway, so we got some data here coming back from our API call. If I were to, I can just queue the same task again, and then I would expect that it would append the same data. That's not normally that's not normal operation for this. What normally should happen is that the worker will continue processing while there is a cursor in the response. So let's work on that. So what I'm going to do is I'm going to delete this key. It's like it never happened. Okay. And then we're going to go and we're going to work on the next step. Let's do some coding. Okay. So how are we going to do this? Is there a do while loop in Rust? So I could just like Google that. I could have Copilot try to write it for me, but honestly, it's sometimes easy. It's just to try. A lot of languages have. Wait, what am I doing with a loop here? Oh right, no. This is the loop for processing the tasks altogether. But if we're processing a single task, wait. So I have an infinite loop here. Yeah, where we're just processing tasks until the end of time. That's fine. But is there a do while loop? And honestly, kind of the easiest thing to do may just be to, let's see here. Where do I want to start that? Can we reuse this client? Like we've constructed this client. Can it be reused, or do we need to construct a new one each time? I just have more and more questions. Hold on, maybe it says here. Okay. You don't have to wrap something. You don't have to wrap something to reuse it. It kind of implies that you can reuse it. Holds a connection pool eternally, and so it's advised that you create one and reuse it. Okay. So in that case, maybe what we want to do is we want to take this and we want to move this to the top of up here, kind of like where we're creating the connection to Redis, and reuse it across the run of the task worker, right? So this task worker is processing things serially. Our parallel processing comes from the fact that we will be running multiple task workers. Okay, so this here is kind of where we start processing the task. And so what if we just did, can we do a do loop? A do while? We're going to find out. If I could use my keyboard. Hold on, where is the curly braces? Over N and E. Oops, yeah, over here. Syntax error. Okay. Okay, maybe I will Google. Rust. Loop. So basically what I'm after is I want to have a loop where the continuing condition, the thing that says the loop is going to continue, is at the end, right? So there's a loop keyword to indicate an infinite loop. Let's see, do we have navigation? So there is if else loop while for and range match if let else while let. Similar to if let, while let can make awkward match sequences more tolerable. Yep, nope. I mean, we could just use loop, right? And then have a condition at the end to exit the loop. Since there doesn't appear to be a do while. So what we're going to do is we're going to say loop while the cursor is not null. Specifically null. Oh, it means it got very quiet. Why so quiet? All right, and so the end of the loop is when we have, let's see. Oh, hey, Runacrow. I see you found my animated emote. How are you doing? Right, so yeah, so after this is kind of where we want to resume the next pass, right? So we've stored the data from calling the API. And so we want to do this. And then, so I don't think that's going to work, but let's do, there we go. I couldn't actually get on my families for the holidays like I planned, so I'm home hiding from the roommate's family. Well, yeah, I guess that could be an awkward situation depending on your relationship with your roommate. I'm sorry that you couldn't make it out to your families, but thanks for coming by and hanging out here. Do you code much, Runicra? I don't know if we've talked about that before. So does this work? Returns true if the value is null. I did a little bit of coding when I tried getting into web dev, but found that making websites for other people was boring. I plan on looking into Godot sometime soon though and seeing what I can do there. Plus I've done some modpack stuff, but never anything major. Yeah, I want to say, so Quill18, who's, you know, someone who does videos on YouTube and on Twitch as well, I think he was doing a thing on Godot fairly recently that I was looking at. Their kind of out-of-the-box scripting language looks Python-esque. It looks kind of interesting. I did a Let 'em Dare once with Unity, but I've not really done a lot of game dev. Just little things here and there. Yeah, making websites for other people can be, I mean, it depends on what they want, right? And how much creative liberty they give you in doing it. It's been a while since I've, that was kind of where I started though, was just doing like, you know, working with the designer, and they have a design and it's just like, take this image and turn it into a static website. That was a long time ago. But, especially back in the day, if you had a designer that didn't necessarily know all the limitations of what was practical. It can be kind of interesting in a maybe not so fun way. Alright, so is this gonna work? So our API, so what we've not looked at today is the actual like API that we're calling from here, which is the silence detection API. So let's go over there. Actually, maybe I had the file open already. So here's the API somewhere in here. Detect segment. All right. Yeah, we still have this to do because this is waiting on us to make the task infrastructure so that we can front it. But we have the internal piece, which is detect segment. That's the thing that we're calling from Postman right now. And so if we are done, I think we have a case here where if like this is the last file in the list of files provided. Yeah, we return none here for cursor, and I'm pretty sure that means that it should be null in the response, but we can check that by going over to Postman. And what we'll do is we'll take this value. So this is how you're supposed to use the API, right? But programmatically, typically, is that you, like, this is the initial payload of the video files with audio tracks that we want to look for segments of silence in. And then once you call it once, it basically just processes the first file, right? And then it returns a cursor that would tell, that has something that you're not supposed to know the details of, that you take and you pass in, and then it will process the second file. And so the response for this one should have a cursor that has like a null, maybe, or maybe it'll be undefined, or maybe it will be just not present. I'm not exactly sure, so we're going to find out exactly what that looks like. And this usually takes, well, apparently last time it took 46 seconds. So behind the scenes, this is running FFmpeg to do a filter that's looking for quiet sections of audio on the specified track. Yeah, so it returns a null. Okay, so I think if we want to take that in as like that's the contract for what the API is going to do, then just checking to see if the cursor is null means, hey, we're done. If we're not done, then we come back up here. So this is where we need to modify payload JSON to add the cursor. So we can't do that at the top because we don't know if this is the first time through or not. So what we need to do is down here, do this, right? Because the only time the only time we visit line 86 is when the cursor is not null, and that we're going to go back to the top of the loop. Now, cursor here is a value. Do we need the clone? Can we get away without the clone? Let's see if we save it. Does it yell at us? Yeah, it does. Expected value, but found a value reference. Right. So this takes a value. I mean, in other languages, I would just do this. Does that work in Rust? Yeah, cannot move out of star cursor, which is behind a shared reference. Move occurs because star cursor has type that value, which doesn't implement copy. Okay, so I think, but this doesn't yell at us. So cloning here is like returns a copy of the value. Now that's probably a good thing because like this cursor inside this response, right? So there's some memory location that holds the value from our HTTP response inside of the scope of this loop. And what we want to do is we want to smuggle. We want to take the value from that cursor and we want to share it with the next iteration of the loop, right? So what we're doing, and that's why it's kind of, so Rust has a borrow checker. And the purpose of that is to keep you from doing things like taking a value that belongs to one part of the code and basically giving a reference to it so something else can use it even though the thing that actually owns that is like, oh, I'm done with this, I'm going to throw it away and let the system use it for something else. So those kind of data, those memory leaks and those shared pointers are a source of infinitely many bugs in like C and C++ programs. Although, yeah, I've made many of those errors back in the day when I was programming in those languages. And that's kind of one of the big appeals. Besides all of the kind of the modernish conveniences in a systems level programming language that Rust has, like the match syntax and the better types and enums that have fancy capabilities, but that borrow checker is a big draw for like a systems level programming language that is Rust. Okay, so this might work, right? So we're going to take the cursor from the previous response and we're going to make a copy of it and put it in payload.json. Payload.json was created outside of the loop, and so this is coming from our deserialization of the value inside of from Redis that we're going to mutate to put in a new cursor from the response from the API, and we're going to loop over and like make the next API call, and we're going to repeat that until we don't get a cursor no more, and then we're going to break, and then we'll be done, and then we'll tell Redis that we're done processing the item. And then this is not a do anymore, it's a do done. And I guess we didn't need this this use after all. All right, so that's task worker, I think. Maybe. Maybe. Things I could come back and do later are actually add the tracing instrumentation like our APIs do. So that instead of using print, we can use trace, and we can have, you know, it's like diagnostics and stuff later. But this is fine. So let us get everything built and running, and we can potentially actually see this work. Now, if y'all want to do me a favor, if I say something particularly interesting or explanatory, feel free to make a clip. Or if I say something very silly or maybe not so intelligent, also clip that. We can have a laugh. I mean, turnabout is fair play. I was clipping all sorts of silly things that were being said on other people's streams the last couple of days. All right, so... Oh, that was fast. I think we should be able to see this kind of working, right? So if we... So we've kind of reset, right? So we don't have the data array anymore. And the temporary queue deletes itself, right? So we're going to queue up our task 1 again. We'll go back over here. And we can already see there's a temp queue, because the worker is working, hopefully. Go back over to Docker, and we can go over to task worker. And this will take a minute. Right, so I think we're not... Okay, I think we do print like the response we get from calling the API, the silence detection API. So we'll see in like 30-45 seconds the first response coming back. Hey, Cambrizo, thanks for the follow.
Cambrizo just followed.
Welcome. we're just waiting. Oh, there we go. We got a response. So we should see another list here with our data. So we'll see one element here. So this is the response from our first API call. And you can see it doesn't say that we completed, which is good because now it's going to take the cursor with an index of 1 and it's going to call the API again. And the utility of this, the purpose of this, you know, I mean, it's well and good that it can do, like, it's detecting silences, but there we go, and it finished. But this can be used for any of our, like, microservice APIs where we are needing to process, like, either sections of, like, audio or video to find something interesting or to transcribe text or speech to text or whatever else we're trying to do that might take some time. This is going to manage that for us in the background, doing that, because you know that took like a minute or two to process. Things could potentially take longer. A fracture appears in chat, some kind of Pokemon. I know so little about Pokemon, but it's something fun to have going on. There we go. And so we have both of the API results captured. And we do need to make some other APIs in some other endpoints in the task API. You know, we've been working today and a lot in the last coding stream last Sunday on the task worker, but we have a task API that's responsible for queuing up tasks and reading information about tasks, like what their status is and what the data is. So we'll have to read all this stuff out. But there we go. The temp queue went away. We ended up just not mutating this at all. We created a new key that has the actual results in it. So these are all the different silences that were found in those two video files. Fox is going after it. All right, so success. So what have we changed here? So we added persistence to our Redis. There we go. Oh, it escaped. Oh no. Oh well. So one thing I mean it's kind of hit or miss, but with GitHub Copilot, there's this thing you can click here, little sparkles, that'll generate a commit message for you. So add volume for Redis data. Yeah, that's sort of true. That's sort of what that did. And then here is what we just did today, right? To add the ability to actually capture the value from the API in the task worker and to iterate over it. So that was, what are we at? An hour and a half. But that's how things go. Sometimes a few lines of code take a lot of time. Sometimes lots of code gets written in a little amount of time. Yeah, implement data retrieval loop is roughly true. So I'll just go ahead and push those. C, mark C if you're still around. I do push up things to the repo on the regular basis when I am working on them. All right, so for now, that's the task worker. So I have this plans document from a couple weeks ago. Let's see, how are we tracking on this? Figure out how to have tasks respond to events from Redis. We did that. I think we did more than that. Set up input output structs for task API. All right, so I think we need to go back to the task API now. And I mean, I'm looking forward to moving on from all this task stuff to actually doing things that do things. But it's the plumbing that we need to have to make it all like come together, right? I think once we we have a few things to do. We need to, because we have made some changes in how we are representing tasks in Redis and how that is all working. We need to go back to the task API and update it. We need to make sure that all the task API stuff then works. And we did this, right? Set up task service to use Redis. We did that. Complete to-dos, and then in our front end, which for those that don't know, this thing has a front end. Where's my web browser? All right, I think we might actually be done with all these Redis documents. Let me close all of this. I'll leave one just so it's easier to get to. So we have a Foxy and her crazy luck. What do you mean? She didn't catch it. Or are you saying that the crazy luck is the inability to catch? I mean, if you really want to catch him, you want to use like an Ultra Ball, right? You get a much higher percentage chance, right? It's only like 30% with the normal ball. So if y'all enjoy lots of data, here's like an example of what we're doing here with the streams, right? So I have the data model here. Sorry, also this is kind of bright compared with other stuff. The data model here is you have a stream, and the stream is like the stream that I'm doing right now that you're watching and or listening to. And then there are video clips. Video clips here mean just like segments of the video, not like Twitch clips or anything. And then we have like, here's the file where the video is stored, and here's the duration and ISO 8601 duration formats, and here's bit rate and width and height and all these sorts of things. So I have all this metadata. I actually have a tool built into this UI here, scan for clips, that like if you give it a prefix, because all the files have like the prefix date in the name, it will actually scan the disk for all the clips and use ffprobe to pull in all this metadata. So it's a whole thing. And then the things I want to do here are like make it easy to like identify where the actual different parts of the stream, like when I take breaks, where the breaks are, and break them up into episodes, and then be able to eventually like AI detect interesting like things for clips maybe, or for shorts, or to help me do editing and those sorts of things. And also one of the initial use cases that I came up with, and I actually we have some things to do it already, are to take the audio of the streams and specifically per like YouTube video, extract out the speech, turn it into text, and then summarize it into a description to put in the video. And this is something I've been kind of testing with as well, from both ends. And what I mean by that is both taking, like we've done tests with Jupyter Notebook and other things from the API side of things. And like we worked on a React component to have like a pop-up chat widget to be able to like iterate on descriptions and stuff within the UI. So from a code perspective, but then also what I've been doing recently on the videos that I make, like the VODs that I upload to YouTube, is I will take I'll use YouTube's subtitles that auto generates. I'll take that and I'll go over to ChatGPT, and I'll be like, take this, and I have a prompt, right, that I use to say, I don't know, it's like as a component, content marketer, something or other, generate a description for a YouTube video based on the transcript of the segment of a Twitch stream or something like that, right? And so it generates a description, and that's what I've been putting in the videos on YouTube, which, you know, I am small potatoes, both here and on YouTube, but you know, it seems to help a little bit with, you know, it gets the keywords in there, and I don't have to type it all out. So, anyway. We have a UI, and more stuff will be going in here as we progress through the project. Okay, got a little bit of time before I need to take my next break. So let's actually do some more coding. How about that? So let me refresh myself on what we have going on here. So this is in Task API. We have a main function that uses our, well, we get a connection to Redis. We've already seen that. And then we have a common API lib. This is a thing I made a few weeks ago to make it, to take all the kind of reused things for making a HTTP API using Axum. We are using Axum here as a web framework in Rust. And we're defining our routes here. So we just have 2 routes, one for tasks and one for tasks:"record ID. And the only thing we've implemented yet is the create handler here. So if you do a post to tasks, this happens. And right now this doesn't do a whole lot. It does create a task record. We use HMSet to set things, set various keys and values. Right, so this is kind of where we left things. So what we need to do is we need to define what the body of the request is supposed to look like, because we've not done that yet. So I don't really remember how that's supposed to work. So let's go look at one of the other APIs that I did do this for, and figure out how that's supposed to go. Okay, so here's an example of where we're taking a JSON request body with a certain format. So let me copy that, and let's just do like a split view here. There we go. So on the right is our silence detection API, where we had like an example of this taking a post body. And on the left is our task API that we're actually implementing things properly. Okay, so we'll just paste this and we'll update the text here in a second. Okay, so we're gonna need to import some things, but the input here is gonna be, we're gonna call this is gonna be a struct that we're gonna define called, I mean, we could just call it create input, or maybe create task input. Okay, so we can quick fix to import Axum JSON, which is the bit that we're missing there. The warning won't go away until we save, the way this is set up. And we're just gonna create, I think Copilot is gonna do this for us. There we go. Of course, this is not what we want, but it's a start. So the actual things we need for the create task input are random emotes. Thanks for the love, Foxy. Lots of people hanging out here today. Oh, it's appreciated having some company working on a project. Oh boy, I'm so easily distracted. But that's fine. You gonna go get ready for a Christmas party? Awesome. Well, thanks for lurking, keeping that viewer count up, I guess. Hope you have a good Christmas party. going to be doing that. I think folks are coming out the day after. Some friends and stuff are a little sick, so we're doing a post-Christmas party. All right. So what is the input? Well, we know what we're putting in the task in Redis. All right. Which is like a URL and a payload, and we're putting an ID, but we're generating that as a reference. What does that look like? Right. So in here we have a hash, right? And we have a URL and a payload and a data key. So we could. I don't think I want to bake into the task API knowledge. Like, the whole point of having that data key and those things is to not bake in all the details about every single microservice we have. I mean, it's not like we have thousands, but the point is to this is the interface that we're defining, and this is kind of the separation of concerns, right? So the task service as a whole doesn't need to know many details about the APIs, other than the fact that the API response and request have this like cursor that it uses, and everything else is kind of not defined. We're also going to say that, wow, this is tricky. We don't. What we could do is we could just have the create task input have the URL, right? But the intent is going to be for the front end to call. No, it's not. Generally, well. So a thing we've not touched on at all, and the way I'm thinking of doing this right now, we will need to at some point, if this were to ever be a thing that we actually put on the internet, which I don't have any immediate plans to do that, but you could run this locally, which is how I intend to use this for the foreseeable future. But a thing that we've not touched on at all is like any kind of permissions or access control, and I think what we would need to do in order to do this, where we just pass in a URL, is to lock down who can call the create or just this API at all. The main intent for this API is to be called by other APIs, and then so it's just like used internally. But then some of the other endpoints, like task, like this one, to get the information about the task, would be called potentially from our front end, right? So having different routes have different, like, who can call them, and those sorts of things would be relevant. In the short term, what I'm just going to do is I'm going to just take the things that we want to put into the Redis record, and I'm going to just have them in this struct. And we're going to take whatever's in here, we're going to put it in Redis. We're just going to trust the client, which you shouldn't do. Generally speaking, but we're not working generally. We're working specifically at the task at hand, and that's what it is. So this is going to be a string. Thank you, Copilot, and then a payload. Can we do that? Will that work? Yeah, it doesn't. Oh, we haven't imported. Okay, so if we import that. Okay, so far so good. Yeah, we're not using those fields yet, but we will. We will. Okay. Yeah, to do get request body contents. Use that. That is what we're working on. Move this to an Axiom extractor. That's definitely a thing we could do. Is like move our connection handling. We did this with Postgres and other places. Did we? Yeah, with Postgres and other places, so that you could actually, instead of getting the state, or maybe in addition to getting the state, you could also have a custom extractor, which is what was going on here. that just gives you the Redis connection. This may be the only API that's actually using Redis, so I'm not going to do it yet. We need to have a couple more examples of something before I bother doing it. Okay, and all this stuff is fine. Like, this is us getting the connection. We're calculating the next value from task counter to figure out what the unique ID is going to be for the next task. And then we're generating a key from that. And then we are creating a hash at that key. So now what we're going to do is we're going to store URL and payload. URL. I bet if I just delete this, Copilot, yep, will write it for me. And then payload to string. Does that work? Let's try saving it. Yeah. Maybe. Hey, Omen Afflictions. Sorry. I said that kind of weirdly. I think that's the first time I said that out loud, but welcome. How are you doing? Merry Christmas Eve. Which it's 10 a.m. here. It's not even, it's still morning. It's Christmas Eve morning over here. Not quite Christmas Eve, but still. Okay, this might work. I'm all good. You doing well? Just at work, sadly. Oh no. Well, I hope that you were at work because it is a necessary function that needs to happen respective of the holidays and not for unnecessary reasons, let's say. And I hope you are being well compensated for that. I can't really talk. I have been on vacation since the end of November. And it's gonna be really weird going back to work on January 2nd. Sadly, I'm not going to be able to hang out in as many streams, especially in the middle of the day my time, as I have been. Return the created task record. I guess we can do that. I mean, we're not going to really return the record. We're just going to generate some JSON, right? It looks like it. Like that. We're just going to spit back the thing that we got. Oh, you're very welcome. It is for a good reason. I'm glad to hear that. It doesn't like that. Right. Okay, can we move occurs? Yeah, so here we go. Here's the whole borrow checker thing, right? We have this body.url, right? So that's a string. It's a memory location, and we're using it here. So we're like, how are we? What are we doing with this? What does it mean? Value moved here. So by passing string to arg, we move it. So here's a question. If we put this here, does that change the situation? I guess so. So instead of giving the value over to this arg function, we're passing a reference to it. It seems to like that. Okay. And I think maybe this is it for the Oh yeah, to do used request body contents here. Well, we did that, so to done. Okay, do we have any unused imports? No. Good. Okay, so I think maybe the create handler is done now, which is good. Unless I'm missing something. I am missing something, right? Oh yeah. So the I mentioned before, right? So some of the semantics of how we are using Redis, and what I mean by that is like, in other words, the conventions, the way that we are using the data structures in Redis to represent what we're doing has changed. Right before, like 2 streams ago, I had talked about we're going to publish a message to like a pub sub channel, and there was going to be a listener, but that doesn't really make sense given what we're doing is very, very much more fits with using a queue, which I think I went on at some length last stream. So what we want to do is we want to push the ID into our task queue. Now, do I have the... I don't think I have the name of the task queue and task API. I think maybe that was something that was in the plans, and I just didn't pick up that was what I was trying to say. There we go. Queue name. Right. So task worker has queue name, but task API also needs queue name. Oops. Shift tab a couple times. There we go. So that provides the environment variable queue name to task API, so the task API can know where the queue is. It would be amazing if Copilot just wrote that. Let's see. QU, EUE. Yep, that one. Except we don't want to use expect here, right? Because if we use expect, then this will panic. And that is not friendly to the clients that are making the API call here. So instead what we want to do is we want to say let match and then get rid of that, and Copilot will write the rest of that for us. Right, so we're gonna call this function, right, and it's going to look up the environment variable for us. And the value is okay if the environment variable is present in valid Unicode. That's nice. So if it's okay, we'll just take it, and otherwise, if there's an error, we'll trace it, and we'll return a 500 error. And so now QName is a string. Something that threw me off, I think the first time I saw this, is that this return does in fact return from the function, right? The return here is never about like the match expression. So this allows you to bail out and handle like an error condition from this result. So a result of a string is either okay or error. Okay, so now we have a queue name. So what we want to do is, instead of publishing a message to the task channel, we want to do something else. Add the task key to the queue. Correct. Love it. All right, so it wants to push to the head of the list this key, and then we'll do some tracing on whether it succeeds or fails. So the question is this what we want to do? Do we want to put it at the head of the list? How are we reading in task worker? Right, so if I do Control P We'll look for task worker main.rs. So when we are reading, it looks like source direction is right. Yeah, so we target the last element of the list in our blocking move operation. So it says pop an element from a list, push it to another list, and return it or block until when it's available. And then source direction, I believe this should be reading from the right of the list. So if we want first in, first out, that is, we want the first time you call the task API, whatever thing you send, that should be the first thing that's processed. Like if you send a bunch of things, it's processed in order, right? So first in, first out. If we want to do that and we're reading from the right-hand side of the source queue name, then we want to push values to the left. So they go in on the left-hand side and they come out on the right-hand side. And that's it. Right, so we create our task record. We have an ID and a key that encodes the key for that. And then we push that key onto the queue. And we're done. Everything else is handled by the worker over here. Oh, I was looking at what was different here. Like right here, we're getting Redis URL, but we're not doing that here. But over here, we have something up here where we're encoding the Redis connection in the app state. It's a little different. Okay, and so with that, what we're going to do is we're going to hope that all of this works. Excuse me. And we're going to test this in a minute. So what we're going to do is we're going to actually cancel out. Hold on. Something's wrong. It doesn't like something. What doesn't it like? Lpush. Okay. We've seen this before. So it gets confused because we don't really care about what the response is. So if we just need to have something here to say, okay, we have like an ignored unit response. So hopefully that will not make the error go away. Okay. What do we need to change here to make this happy? Something. Temp queue name is a string. Interesting. Okay, well, we're going to take a break for just a couple minutes, and I guess I'll figure this out when we come back.